waveforms when light enable and light read functions are executed. So let's see here. If you look at the visualizer, you can see that actually I have made connections in such a way that SCL and SDA are connected. Okay, in fact, the pink connection, the pink wire goes to SCL and the green wire goes to SDA. In fact, all the LPC pins are available there, as one block. So I'm just tapping it out and trying to see it on the oscilloscope. Oops. Okay, that's bad news. Give me a moment. So I will be executing this function. Sorry, this row display 1. And all this function, or all I am doing here is, see here, yeah, all I am doing here is I am having a while loop inside which I am just doing a repeated light read function. So I am just repeatedly doing light read over and over. And the reason why I am doing this is so that I can see it on the oscilloscope or protocol analyzer. Okay? So I am just trying to see it. So let me just run it for you. But before I run it, let me just ask you this question. Yeah. So the number of bytes sent or received, that is the total number of bytes going back and forth in the process of reading the light sensor is. So I am essentially running the light read function which is supposed to read the light sensor, right? So how many bytes are transacted? That's a question. Is there any tutorial just to help you recall the total number of bytes going back and forth when you do a single light read, when you call the light read function? Okay, 5, 4, 3, 2, 1. And let me look. And let's try running it and let's see. So, oh, I haven't run it yet. Okay, so now it is doing a light read in a repetitive manner, and you can see it here. You can see all the transaction here, in fact. So what does it do? First, you can see it is hex 44 WR. What does it mean? It is the slave address is hex 44 followed by a write bit, which is essentially hex 88. That is actual stuff sent. It is hex 44 followed by write bit. And then the slave will, you can actually see there will be an acknowledgement from the slave. And the next thing that you send is hex 04. What is 04? Yeah, the slave register address, because reading the light sensor is a two-step process where first you read the LSB sensor and then you read the MSB sensor. So you are first sending the LSB sensor address, the slave acknowledges, and then you will stop, and then there is a new start. And you can see the stop condition here, right? So stop condition is data going from, this is SDA, data going from low to high while clock is high. That is stop. But then it is followed by a next start. So start is the data going from high to low while clock is high, this part. Okay, not very visibly clear, but yeah, it's clear. Okay. So essentially you have a start here and you have a hex 44, which is a slave address, followed by the read bit. Okay, and then the slave will acknowledge, and then you get the first byte of the reading, and then the master, you can see the master does not acknowledge, and then you have a stop. So this, what you see is exactly what we have here. Here, start, slave address followed by write, slave will acknowledge, then you write hex 04, this is actually hex 44 shifted left by one position and appended with a 0, which is write. Okay, then the slave will acknowledge, and then you stop, another start, here it is hex 44 shifted left by one position and appended with a 1. Acknowledge, then the slave will send the data, the master won't acknowledge and stop. This is how you receive one byte of the reading, but the reading is in total 2 bytes. So this whole thing has to be repeated, but this time instead of 04 it's 05, and the reading here will also be different. So the total number of bytes transacted is 8, and that is what you see here. So here you see, this is one complete light reading, and here you see hex 44, it's hex 44 followed by write, then you write 04, then you do a read, you get the first byte reading, and then you do a write again, and what you write is 05, which is a MSB sensor address. First you send the LSB sensor address 04, then you send the MSB sensor address 05, and then you do a read, and then you get the most significant byte. So in total you receive 2 bytes, but the total transaction involves 8 bytes. Which are the ones which are sent by the master? This is sent by the master, sent by the master, sent by the master. This is sent by the slave. This is sent by the slave. And when the slave sends 1 byte of data only, you don't acknowledge because the last byte received is not acknowledged, right? And then the whole thing is repeated. So, but this time you send the 05 slave register address, and then you do a read, and the slave sends you the MSB reading, and then the master will not acknowledge, and then there is a stop condition. And this whole thing is one single light read operation. So a total of 8 lines, right? You can actually even see it on the oscilloscope in the lab. Okay? You know, sometimes when things don't really work, I actually connect the oscilloscope and see whether the clock is getting generated, whether the data is getting generated, etc., etc. Okay? Instead of wondering why you are not receiving the data, you can actually see whether the data is getting transmitted. Okay? An electronics engineer should be able to use oscilloscope, because oscilloscope is called the eye of the electronics engineer. You see what is happening, okay, rather than doing the guesswork. Now I will show you that instead of doing it directly, in fact, if I can also show light enable being done repeatedly. And how many bytes are transacted for light enable? Light enable is in fact 3 bytes. It's just a one directional transfer, because you send the slave address followed by the write, the slave will acknowledge, and then you send the slave register address, which is 00, because you are writing to the command register within the slave. And then what do you write to the command register? The command to enable, and the command to enable is 1 followed by all zeros. And you can see that this will be X80 and only 3 bytes. Okay, one direction. The slave doesn't do anything other than acknowledging the bytes received. So here you select the slave, select the register within the slave, and then write the command to enable it, or put a 1 into bit position 7. That is 1 followed by all zeros. That's 80. Okay? And now let's see that in action. Let's try running it now. And now, if you look at the waveform, now you see, here it's all 3 bytes. The first byte is 44, the second byte is 00, the third byte is 80. It's consistent with what we saw, right? 44 followed by write bit, which makes it 88 in fact, 0080. And that is exactly what it is in our notes, right? The 3 bytes here. Yeah. So now you see, I was not lying to you. That is really the case here. And now, next thing I am going to show is a low-level implementation of light read. You know, we were happily using the light read function, right? But like I had always mentioned, we cannot just be users. What happens inside the light read function? Give me a moment. Yeah. So if I look at inside the light read function, let's see what is inside. Light read function internally uses I2C write and I2C read. And I2C write, I2C read internally uses the same function I2C master transfer data. And that internally uses these functions, such as you can see it is I2C start to send the start condition, I2C send byte to send the slave address, and followed by any other bytes if you are writing. Then there is I2C get byte, I2C get byte to read the data, and then there is I square c stop somewhere. And you can see at the end of it, master transfer data, there is an I square c stop also. So all functionalities are internally achieved using just 4 functions: I square c start, I square c send byte, I square c get byte, and I square c stop. And if you look at past year papers, you can see that there were questions where you are supposed to use only these. You cannot simply use light read or something of that sort. Then you have to know what is inside. Okay, and once you know what is the sequence of operations, it's quite natural. But let's have a look anyway. So this is, oops. Yeah, now I have a low level implementation here. So you see here, this is a low level implementation of what? It's light enable. I am not using light enable here as a one function, but I am achieving light enable using this. So light enable is, you start, then you send the byte 88, which is nothing but slave address followed by the write condition. Then you are sending 00, which is to select the command register, and then you are sending 80, which is a command to enable, and then stop. So essentially, you can simply use this instead of light enable. Light enable internally does the same thing, right? And similarly, you can achieve light read. So you can see start send byte, then send byte 04, and then you do a stop. That is sending the address of the command register. And then you start send byte 89. Why is it 89 here? Because it's a read operation. And then you are calling get byte to read the data, and then stop. And then the whole thing is repeated with the next time 05 instead of 04. That's the idea. Okay. So you can see everything is achieved just using start, send byte, get byte, and stop. Okay, there are some unnecessary lines in between because I have added some additional functionalities here and there. But you see, the same thing can be done too. And now let's try and call this. And now you see, without using light read, I am achieving that functionality, but in a bit of a low level way because I am using start, get byte, send byte, etc. And now you can see it effectively achieves the same thing, right? You can see this is like 44. See, this is sending the slave address, slave register address, LSB sensor address, then reading the data, then sending the MSB sensor address, reading the data. Now you see the exact same thing is achieved, but without using the higher level functions like read. But it's the same thing that is achieved here. Okay? And do you want the value to be printed? If it is to be printed, I have just conditionally commented out print. If you want it to be printed, then I can just uncomment this. See, what I am trying to do is to print, right? And then if I just uncomment this line, you can see that now the part for printing also becomes uncommented. Okay, and now let me just try running it. Oh, not sure why it's not running.
每天他们发吃，我得看看他们吃的啥。
If it doesn't run now, mind, I will just move on. Possibly some connection issue. So anyway, that is the idea. Now you can see that this is a low-level way of implementing it, right? Now, in fact, what we do here is in the light read, we have these as completely separate transactions, right? We effectively have 4 separate transactions. In fact, is it necessary to send a stop condition here? Actually, no. Is it necessary to send a stop condition here? Not the first time. So, in fact, there is one more of this whole thing here, right? So, all the 3 stop conditions are actually optional, and the last one is good enough. Okay, so if you go back to my code, here I have a mechanism whereby I can just use a repeated start condition. So when I enable repeated start condition, what I do is the 3 stops. So one stop here, the second stop here, and the third stop here are all uncommented. Okay, and it still works. And now I am using repeated start instead of stop. And now you can see it is labeled as restart. So it's essentially there is no stop here, but I am starting again. So here you see, following a not acknowledged by the master, we are restarting. So it's a start condition without a stop condition in between. Normally there is supposed to be a stop in between these two, right? But now I am not having that stop. And things still work the exact same way. Now, interestingly, the way they have implemented light read function is in fact pretty inefficient. You know why? Because light sensor and many other slaves support something called an auto increment. So one way to read the data is, okay, normally what we did was, so we sent a start condition, slave address plus write, and the slave will acknowledge, and then you send the slave register address, which is a 04, and the slave will acknowledge, and then you send a stop condition optionally, and then you send the start condition, slave address plus read, and the slave will acknowledge, and now you have the slave giving you the data. So the slave gives you the data and you don't acknowledge, and then you stop. And then this whole thing was repeated and the whole thing was repeated, right? And the whole thing was repeated, but this time with 05 instead of 04, right? And what you get here what you get is essentially the LSB reading, and here what you get is the MSB reading. So this was a procedure, right? In fact, the only inefficiency you have is not just these being optional. Of course, you can remove that and achieve the same functionality. But in reality, you can read it all in one shot. So the equivalent of this will be start, slave address plus write, and then the slave acknowledges, and then you will send 04. So the first part is the same. Okay? And the slave will acknowledge, and then you can optionally send a stop. And the next one is a read operation, right? So in the read operation, you have start, SA plus read, and the slave will acknowledge, and the subsequent byte comes from the slave, is acknowledged by the master, and this is your LSB reading, right? Now, this much part is exactly the same as this, no difference. But now, what you can do is read once more. I mean, expect 2 bytes. Sorry, here it was not acknowledged. Here you acknowledge. The slave will send you 1 more byte. And you know what is this byte? The MSB reading. And then the master can not acknowledge, and then you can stop. So instead of doing this, you can actually do this. The way they have done is actually quite inefficient. The light enable function is in fact poorly implemented. A better way to implement would have been this. Now the question is, how does it work? How can it work? Here you ask for the LSB reading, you got the LSB reading. You ask for the MSB reading, you got the MSB reading, right? Whereas here you are asking only for LSB, and then you are expecting the light sensor to give you 2 values. How are you expecting the light sensor to give 2 values? Because you are not acknowledging here. Sorry, here you are acknowledging, not acknowledging. Here it was a not acknowledged, right? So if the master acknowledges, it is telling the slave, I want more data. So the slave, when it is asked for more data, will automatically give the data in the next register. So this is what we call auto increment. So if you are asking, typically if you ask a slave for 4 bytes of data, after giving it one register address, it will give the address, sorry, the value in the first register, then the next one, then the next one, and then the next one. Yeah. Sorry. Oh, sorry. Oh, sorry. Yeah, that's right. Sorry. Slave cannot send the stop. So